Hey there, and a massive welcome to all the 8th graders joining us for today's Explainer. I am absolutely thrilled you're here with us. Today, we're diving straight into the heroesmartacademy curriculum for what's really an incredible journey into the world of geometric formulas. We're going to see how this material completely flips the script on how you look at math. We are moving way past just memorizing random numbers and stepping into mastering the actual language of the universe. So get ready to conquer these equations with total confidence.
So here is our roadmap for today. We'll start with the blueprint of creation, shift our mindset in tools, not traps, and then get hands-on with isolating the triangle and mastering 3D shapes. After that, it's your turn to solve, right before we wrap up with the big picture, education, morality, and peace. Let's get to it.
Starting off with Section 1, the blueprint of creation, exploring God's laws. Right off the bat, before we start moving any letters or numbers around, the source material sets this really fascinating foundation. Think about it. From the perfectly symmetrical shape of a falling autumn leaf to the incredibly precise, predictable orbit of a massive planet, there is order. The curriculum highlights that the formulas we study in geometry and science, they're actually describing the laws that keep God's creation running so incredibly smoothly. These aren't just arbitrary numbers made up to confuse you. They're literally the hidden code describing the handiwork of the universe. How cool is that?
Moving right along to Section 2, tools, not traps, preparing to solve anything. Okay, let's dive into this. The curriculum really pushes a major mindset shift here. For way too long, you might have looked at a math formula as sort of a trap. You know the feeling, right? You're sitting there, waiting for that perfect setup on a test where they just hand you the base and the height, and all you have to do is multiply to find the area. But wait, what happens when you know the area and you need to find the base? Well, if you treat the formula like a rigid trap, you're stuck. But if you treat it as a tool, you can just rearrange it to figure out exactly what you need. It's honestly just like life. Sometimes you don't have all the answers handed to you on a silver platter, but with the right tools, you adapt, you pivot, and you solve the problem anyway.
Now, to actually use these formulas as tools, we need our master key, and that key is inverse operations. Think of inverse operations as the mathematical rewind button. It's the way we undo something. If an equation multiplies, well, you divide to undo it. If it adds, you subtract. If there's an exponent in your way, you use a root. These actions, multiplying, dividing, factoring, these are the exact techniques we use to isolate a variable. We're basically pulling it apart from the rest of the equation so it can stand all by itself.
All right, Section 3, isolating the triangle, manipulating the area formula.
So here is our first real test. Let's walk through it together. Step 1, we start with the classic area formula. Area equals 1/2 base times height. But let's say we already know the area, and we want to find the base, b. We need b all by its lonesome. So in Step 2, we use our very first inverse operation. To get rid of that 1/2 fraction, we just multiply both sides by 2. Boom. Now we have 2a equals bh. Much cleaner. But b still isn't alone, right? It's being multiplied by h. So for Step 3, we ask ourselves, what's the inverse of multiplying by h? Dividing by h. We divide both sides by h, and like magic, the base is totally isolated. Little b equals 2 times the area divided by the height. Look at that. You just built a brand new tool out of an old formula.
Let's keep the momentum going with Section 4, mastering 3D shapes, cylinders, and cubes.
Let's step things up into the third dimension. The cool thing is, the rules absolutely do not change just because the formula looks a little scarier. Step 1, volume equals pi times radius squared times height. We want to isolate h, the height. Look at all that mathematical clutter clinging to the h. We've got pi and we've got the r squared. But notice, they are all just multiplying together. And this brilliantly illustrates our next move. In Step 2, we take that entire complex chunk, the pi and the r squared, and we just divide both sides by it. It completely cancels out on the right side, leaving our height sitting perfectly, peacefully by itself. Step 3 shows our shiny new tool. Height equals volume divided by pi r squared. Simple, elegant, and incredibly powerful.
Now what's really interesting here is dealing with exponents. Step 1 gives us the surface area of a cube. S equals 6 times the side length squared. We want to know the length of just one side, S. First things first, get rid of the 6. Since it's multiplying, we use our rewind button and divide both sides by 6, which gives us S over 6 equals S squared. We're close, but S still has that pesky little 2 up top. So what is the exact inverse operation of squaring a number? Taking the square root. In Step 3, we take the square root of both sides, which totally cancels out the exponent. Our final formula, the side length s, equals the square root of s divided by 6. Seriously, you are totally mastering this.
Up next, Section 5. Your turn to solve. Practice makes perfect.
Now, the curriculum offers a really great chance to pause this explainer right here. Grab a pencil, grab some scratch paper, and take a good hard look at these 5 formulas. Your mission is to rearrange each equation to isolate the variable in parentheses. You have absolutely all the tools you need. Just remember your inverse operations. Undo those fractions, undo the multiplication, and undo the exponents. Confidently tackle this homework assignment from the lesson and then come right back to finish up. Go on, you've completely got this. And finally, Section 6, Education, Morality, and Peace, the hero's mart philosophy.
Welcome back. Now that you've totally flexed those mathematical muscles, the curriculum actually asks us to zoom all the way out and consider a really profound question. What's the point? What is the point of being incredibly smart, of knowing how to flawlessly rearrange these complex 3D formulas, if we go out into the real world and just continue to make bad choices that hurt ourselves and others? A sharp mind is a massive, powerful tool, but without proper direction, it can actually be quite destructive.
This brings us directly to the core of the hero's mart philosophy. Education without morality will hurt. The series argues that having brilliant mathematical abilities is frankly dangerous if it isn't guided by a strong moral compass. That is exactly why they purposefully intertwine biblical morality with all this rigorous learning. The goal of the program isn't just to make students smart, but to make them truly wise, encouraging the use of an educated mind to build things up, not tear things down.
And that brings us to our final takeaway for today. The text cites Romans 8, which promises peace of mind to everyone who keeps their mind spiritual. The source material views this as the ultimate end goal, that true intelligence isn't just about successfully isolating a variable on a piece of notebook paper, it's about combining that ultra-sharp mind with a spiritual heart. So as we wrap up this explainer, I want to leave you with this final, provocative thought from the curriculum. If inverse operations bring perfect balance to a mathematical equation, could bringing spiritual morality to your education be the ultimate formula for lasting peace? Keep learning, keep exploring, and keep balancing your mind and spirit. See you next time.